Hi there, it's Miss Manning again. Today we're going to be learning Module 5, Lesson 4, where we're learning to use multiplication to calculate our volume. So there are two things that I want you to keep in mind while you're doing this lesson, and the first one is the layers that we can decompose our shapes into. So we have our cake. We can slice it like a cake going along the length of our shape. We can also slice it like a loaf of bread, where we're looking at that front face and slicing it along the height. And our last way is slicing along the height, but not this front face, slicing it along the height of the side face here. And that's all going to lead us to our multiplication, the standard algorithm of multiplying the length of a shape times the width of the shape times the height of the shape is going to give us the total volume of our shapes. We can also think about finding volume like we did yesterday when we were finding the base of our shapes. I have a base of 4 cubes in this layer, and then I want to make copies of it for each layer that I have. So that would be our base times our height to find the total volume of our shapes. So for our problem set number 1, I wanted to do that one with you guys so that way you could get a sense of what they're looking for. So for each rectangular prism that they've given you, they are wanting you to find the length, the width, and the height of each shape. So remember, my length is going to be along this point right here. So I have 1, 2, 3, 4, 5 cubes there. So for my length, I have 5 cubes, but remember each one of those cubes is 1 centimeter. So I can think of this as 1 centimeter, 2 centimeters, 3, 4, and 5. So I have a length on this shape of 5 centimeters, and the width is going to be this distance right here or even up here, and it's 2 cubes long or 2 centimeters. And then my height is this distance here or even back here or here. Either way, I count 2 cubes, which is 2 centimeters. Now, before we jump into finding the volume by multiplying with a standard algorithm of length times width times height, I want to talk about what we did yesterday in our lesson, which was decomposing the shape into different layers. So if I decompose it like, I'll try to do it wide so you can see it, like a loaf of bread, we end up with a total of 5 layers. But that's not the important part. The important part is to remember we can figure out how many cubes are in one layer. So when we look at this shape here, we can see this is 1 cube, but don't forget these 2 faces right here are also a part of the same cube. So I have 1 cube, 2, 3, and 4 cubes right here in this layer. So this layer has 4 cubes, this layer has 4 cubes, and so on. So that's going to give me a total volume of 4, 8, 12, 16, and 20 centimeters, cubed, because that's our volume here. Now that we've done that, I want to be able to relate what we learned yesterday to what we're trying to move to today, which is that standard algorithm. So we think about this as being one of our layers. And the way that we were able to find out how many cubes were in that layer was because we actually took the width of this, which was 2 centimeters, and we took it times our height of this section, which was 2 centimeters. So we first found out the length times the width, and then what we did is we took that layer and we made 1, 2, 3, 4, 5 copies, which it also happens to be the length of our shape. So if we were to solve this one out, 2 times 2 is 4 times our 5 that we left up here times 5, which gives me a volume of 20 centimeters cubed. So that gives us that standard algorithm. Now, when you go down to 2A, it's going to ask you to write out the expressions that you use. So I want you to remember back to our success criteria, which states that we can find volume by taking the length, and I'm going to write it in a cursive L, which is kind of challenging upside down, but I'm going to write it like that because if I wrote a lowercase l, it ends up just looking like a 1. And so when you're trying to use letters for a formula, you don't want those to be confused. So if I take the volume of the length times the width times the height, I should be able to find my volume. So for 2a, you have options here. I could write out my length, which is 5, times my width, which is 2, times my height, which is 2 as well. And I get a volume of 20 centimeters cubed. Now, the other way that we talked about finding volume was this idea of base times height. So when we're thinking about base times height, that's what we did right here with this layer. We found this bottom layer, this base right here, which ended up being 4. And then we took it, or we made copies of it based on how long our shape was. So base times height would be 4 times 5, which is, again, 20 centimeters cubed. The other cool thing when you are talking about finding volume is this idea of commutative property. So we have the commutative property in multiplication, which is saying that if you had a friend who said, I'm going to take 3 times 2, and you say, but I want to take it 2 times 3, you're going to end up with the exact same thing. We can switch it around. And the reason that we can do that with volume is because while this shape may look like this to you, you may have somebody else who is looking at it here. So even if I think the length of my shape is 5, and a friend thinks the length of this shape is 2, it actually doesn't matter because we're multiplying them anyways. And no matter which way I turn this cube, this rectangular prism, it doesn't change the volume of this shape. There are still 20 cubes or 20 centimeters cubed in my shape. I still have the same volume no matter which way you're looking at it. And that's why we can change around my length, my width, and my height. It's not important that you know that this is length, this is width, and this is height. It's important that you make sure that you are doing each one of these and not accidentally saying, I found the length, the width, and the height, because these two are actually the same measurement. So let's talk about problem set number 5. It says that Aaron says more information is needed to find the volume of the prisms, and I only drew one of the prisms. Explain why Aaron is mistaken, and calculate the volume of the prisms. So they've only given us the area, and we have to remember what we had learned in 4th grade and in 3rd grade about area, and that is its length times width. So when I take the length of this shape times the width of my shape, this gives me an area of 60 centimeters cubed. I don't know what the length is. I don't know what the width is, but I do know that this face has an area of 60 centimeters. And to find this face, it would be length times width. So the way that they want you to think about it is the area that they've given you is like one of our layers. It's one of the layers is 60 cubes, and there are, I'm gonna run out of room. There are 5 layers here. So if I have 5 layers of 60, that's the same thing as doing our base times our height. So they have actually given you enough information here to solve this one. I don't want to solve it for you. I want you to be solving these on your own. But I did want to point out that we talked about it as base, but base is also sometimes the same thing as area. That's all I have for you today, guys. Thanks so much, and I'll see you again tomorrow.